Hello everyone, good morning and welcome back. In this particular video, we'll be trying to understand what do we mean by solubility product, the theory behind it, and the problem related to it. So first, let us try to understand what is solubility product. In a saturated solution of a sparingly soluble electrolyte, two equilibria exist and can be represented as. So you can see the equilibrium representation. Now, before going into that, let us first try to understand what is a saturated solution. A saturated solution is one in which you can add no further solute or electrolyte in it, or it cannot take any more of the electrolyte or solute at a given temperature. And what do we mean by sparingly soluble electrolyte is an electrolyte which is very limited soluble in a particular medium. It is very less soluble in a particular medium. That is what we mean by sparingly soluble. Now, whenever we dissolve a particular electrolyte in such a medium where it is very less soluble, what happens is there exists an equilibrium between two species. One is the undissociated ion, since it is not totally soluble in that medium. So the undissociated unionized electrolyte will remain, and the next is the dissociated ions. So there is an equilibrium between the undissociated species and the dissociated species, or the undissociated electrolyte and the ions which are soluble in it. So that representation of equilibrium can be shown as AB unionized, which is dissolved, and gives you A plus B minus, that is the ions. Now, since the system is in equilibrium, the dissociation constant or equilibrium constant can be represented as the ratio of the product of the ions by the undissociated species. So that is what we can write as A plus, concentration of A plus, into concentration of B minus by concentration of the undissociated species, that is AB. Since the solution is saturated, as we have learned, right, the solution is saturated. If the solution is saturated, that means the concentration of the unionized species will always remain same. That is what we mean by saturation, that the system will not dissociate further, or the concentration of the ions will not increase in the solution. As a result, the concentration of the unionized molecule will remain constant in a saturated solution. Since it remains constant, the concentration of AB can be taken as K dash, which is equal to constant. That is what is written. Since the solution is saturated, the concentration of unionized molecule of the electrolyte is constant at a particular temperature. That is AB in bracket, that is what we mean by molar concentration of AB equals to K dash, which is equal to constant. Now, hence, what we know as equilibrium constant, what we have written, now that particular can be rearranged as concentration of A plus and B minus multiplied will be equal to K multiplied by the concentration of AB, bringing AB to the right hand side. And since AB is constant represented as K dash, so K will be multiplied by K dash. We are just substituting the value of AB as K dash. Now, since K is a constant and K dash is a constant, so when we multiply two constant, we get a new constant, and that constant is nothing but solubility product, where KSP is termed as the solubility product. Now, let us try to generalize it and take a more general equation of the type where electrolyte of the type AX and BY is dissociating. AX, BY, when it dissociate, it gives me X number of A, Y plus, and Y number of B, X minus. Whenever we have this stoichiometric coefficient X and Y in any dissociation equation or in a representation, then whenever we write the equilibrium constant for it, the stoichiometric coefficient has to be raised to the power of the concentration. So that is what we are doing. K is equal to AY plus to the power X and BX minus to the power Y by AX BY, which is equal to K. When the solution is saturated, as we have discussed, the concentration of AXBY, that is the undissociated electrolyte, will remain constant. That is what we represent as K dash. So A y plus to the power x, B x minus to the power y will be equal to K into AXBY, the concentration of AXBY. That is what is the rearrangement. And if we substitute the value of AXBY as K dash, then we get K into K dash, which is equal to KSP. So now if you clearly see what is KSP over here, KSP is nothing but the ionic product of AY plus BX minus. So solubility product is nothing but ionic product raised to some powers, which is nothing but equal to the number of times the ions, or the number of times the ions occur in the equation representing the dissociation electrolyte. So that is what we mean by solubility product. So let me just read it out. Thus solubility product is defined as the product of concentration of the ions raised to a power, raised to a power equal to the number of times the ion occur in the equation representing the dissociation of electrolyte at a given temperature when the solution is saturated. These are the conditions which has to be fulfilled. It has to be a particular temperature, the solution has to be saturated, and in such cases the ionic product is nothing but solubility product, and the ionic product must be raised to a particular power. That power you get it when you represent the dissociation equation and balance it. That is very much important. You must write a balanced dissociation equation. The number of times the ion occur in that particular balanced equation, you have to raise it to the power. That part you have to be careful while solving the problems. So let us try to see the problems so that we can understand it in a much better way. Calculate the solubility of silver chloride when solubility product is of AgCl is 1.6 into 10 to the power minus 10. So in this case, the solubility product is given, and what you have to calculate is how much actually silver chloride is soluble, the solubility at that particular given temperature. Now, as I have told you, it is very important to write the dissociation equation in case of solubility product. So the dissociation equation is AgCl gives Ag plus and Cl minus. Let the solubility of silver chloride be X. Okay, since we don't know, so we are representing it as X. So you can see after that, in that equation we have written X moles. So if X moles of silver chloride will be soluble, then how much mole of Ag plus you'll get? X mole. And how much mole of Cl minus you'll get? X mole. I hope it is understandable, because in the representation and the dissociation equation, you can clearly see that 1 mole of AgCl will give you 1 mole of Ag plus and 1 mole of Cl minus. So X mole will give you X mole of Ag plus and X mole of Cl minus. Now, writing the solubility product expression, KSP will be equal to, as we have learned, that it is nothing but ionic product. So ionic product is nothing but Ag plus and Cl minus. We are not raising anything to the power. That means it is 1. Why it is 1? Because in the balanced chemical equation or in the dissociation equation, the number of times the ions are occurring in that balanced chemical equation is 1. That's why we are not raising anything to the power. And since the solubility of Ag plus and Cl minus is X in both the cases, so we are taking X into X, which is equal to X square. So what will be X? X will be equal to root over of KSP. So if I put the value of KSP as 1.6 into 10 to the power minus 10, what I get is 1.26 into 10 to the power minus 5 moles per liter. Now, sometimes the question is asked to give the answer in gram per liter instead of moles per liter. If the question is asked to give the answer in gram per liter, what you need to do is multiply the solubility product, which is in moles per liter, the solubility in moles per liter, with the molar mass of the substance, that is AgCl, which is nothing but 143.5 gram per mole. You can clearly see one is mole per liter, another one is gram per mole. So as a result, the unit which you get is gram per liter. So that is how you convert moles per liter to gram per liter. That is one of the problem in solubility product. Let us try to see few problems more. Solubility of M2S salt in 3.5 is 3.5 into 10 to the power minus 6. Then the solubility product will be. So over here the solubility is given and the solubility product is told to find. Now, if you see there are 4 options given. Now, how to go for the answer is, again, we need to represent the equation, the dissociation equation. So, M2S will give you 2M plus S2 minus. Now, again, if I take X mole of M2S, then I'll get 2X moles. You can clearly see 1 mole of M2S gives you 2 mole of M plus and 1 mole of S2 minus. So if I take X moles, it will give me 2X moles and X mole of S2 minus. So what will be solubility product equation? It will be ionic product. So ions are M plus and S2 minus. So we are taking the product, and M plus is raised to the power 2. Why? Because the number of times it is occurring in the ionic representation or the dissociation equation is nothing but 2. That's why we are raising it to the power 2. Then the concentration of M plus is twice X, we can see in the equation. That's why we have written as twice X square, and the concentration of S2 minus is nothing but X. That's why it is substituted as X. So if we simplify that, we'll get as 4x cube. And since solubility is given, that is nothing but X, the value of solubility is nothing but 3.5 into 10 to the power minus 6 to the power cube. Okay. And if we try to solve that, what you get is 1.7 into 10 to the power minus 16. So that is how we solve solubility product problems and understand what solubility product is. Thank you, everyone.